Hello everyone, this is Puya. As per your request, I'm posting a video on the concepts of copy constructor, assignment operator, and destructor. This is the review of these three concepts, and at the end of this presentation, I'll show you some examples on how to design and define these three functions for a binary tree class. So first of all, let's do a review of the concept of copy constructor. So whenever we instantiate an object of any class, a function called constructor is needed to basically build that instantiation, build the object. We have default constructor, which is also called parameterless constructor. We have non-default constructors, which are also called parameterized constructor. And another category of constructor that we have is called copy constructor. So copy constructor is called when we are building a new object, we are instantiating a new object by making a copy of another object of the same class. So look at this one, we have a class definition here. The first line, this is calling a non-default constructor or a parameterized constructor. Now let's look at the second line in the main function when we say v3 a1 is equal to a. So here we are instantiating a1. So a1 is getting built at this line by copying another object of the same class into it. So here a1 is going to call the copy constructor of this class to basically build this object, right? So in this case, a1 is calling the copy constructor. Now, in the second parameter that we have, the second object that we have here, like v3a2, this one is calling the default constructor. So here, like we have three constructors called here. This one is calling parameterized constructor or non-default constructor. This one is calling the copy constructor, and this one is calling the default constructor. Now, the default constructor and copy constructor, as well as destructor and assignment operators, are member functions that if we don't have them in our class, if we don't define them ourselves in our class, the compiler would generate one for us. Okay, so the default constructor, the destructor, the assignment operator, and the copy constructor. So even if we don't have the default constructor or the copy constructor, the compiler would generate one for us. In many instances, the one that compiler generates for us is not enough, right? It's not gonna do a good job for us. So like it's needed for us to define our own copy constructor or assignment operator or destructor. Okay, now the copy constructor is called in three different cases, right? So like here you see one of the instances when we are initializing an object at the same time as we are declaring it. So initialization in declaration. This is case one. The second case is like in the next line. You see that here, calling a function myfunc, right, which is defined here, and I'm passing this object, I'm passing this argument to this function, and I'm passing it by value. If you remember, we had three different way of passing by value, passing by pointer, passing by reference. Here we are passing this object by value. So when this a is passed to this function, right? Here we have another object named a, right? But these two a's are different. They have different scope. One of them is defined in the main, one of them is defined in the function, right? So now for a itself to be built, the non-default constructor was called. But how about for this a? This a, which is the local parameter of this function, is also calling a constructor, right? Because each object to be instantiated, it needs to call a constructor. Now, which constructor is going to be called for this a? Here, if you look at it more carefully, we are building this object, we are instantiating this object by copying the other a into it, right? So this is the second instance where the copy constructor is called. So here to instantiate this local object, the copy constructor is called. The last case, which like it's not always called like in every compiler, in many compilers this can be optimized, but this is when you return an object by value. So here when you return an object, if you remember from your previous courses, whenever we return an object by value, the compiler creates a copy of it, right? Creates a copy of it, and this copy is gonna be, because this, when we are returning v, the scope of v is this function. So when we are returning from this function, v is gonna be deallocated, it's gonna be destructed, right? So now how are we gonna return it back to the main function? So a copy of the object that we want to return, it's going to be instantiated. This is done in the background, we don't see it, that object doesn't even have a name, right? And that copy, that's like here the copy of this v object, it's going to be assigned to a2. So in that case, here a copy constructor is also called. But this last case depends on the compiler. In some compilers this step is optimized and we don't see that, like we don't see that the copy constructor was called. Okay, so these are the three cases where copy constructor is called. So a copy constructor, like if you want to define a copy constructor must be specified separately from an ordinary constructor, which is default or non-default constructors. So here you see that in this class, that can be the class of three-dimensional points, right? We have like here we have a non-default or parameterized constructor. Here we have a default or parameterless constructor. Now this one is a copy constructor. If you look at the copy constructor here, like it's called by this calling object and it always needs only one parameter. The parameter, which comes on the right hand side of this equal sign, is an object of the same class, right, as the object that we are instantiating. So here you see that we have just one object of the class v3. In most cases like this is gonna be a constant object. So yeah, that's why like we write constant here. Why? Because when we say v3a1 is equal to a, we don't want to change a, we want to change a1, right? So like this parameter needs to be constant. This constant part is not mandatory to write, But there is one thing that's mandatory to do for copy constructor, is that for copy constructor, the parameter has always need to be passed by reference. The copy constructor, like I'm going to repeat this. So the copy constructor has one parameter, which is going to be an object of the same class. We can have it constant because we don't need to change this parameter inside the function. But this parameter has to be passed by reference. Why is the case? Why is this the case? Because if we don't pass this by reference, if we pass this by value, if you remember, I mentioned that the second case where copy constructor is called is when you pass an object to a function by value. So if we define our copy constructor and if we forget to write this ampersand, if we forget to pass by parameter and instead of that we pass by value, we are going to end up with recursion. So we are going to call the copy constructor within the copy constructor, and this would never end, right? So this would never end. This is going to be an infinite loop and going to be like infinite recursion. So eventually we're going to have stack overflow problem. So always remember that for copy constructor, if we want to define it ourselves, we need to provide the pass by reference. We need to do that by using this ampersand. And in this class, even if we didn't write this copy constructor, the compiler would generate one for us, and the one that compiler generates for us would be exactly similar, like would be doing exactly similar to what we are doing here. So it would be just like copying the member variables of the parameter into the member variables of the calling object. So here, like, it would be basically like if our class has three member variables x, y, z, it would be copying x, y, z of a into x, y, z of a1. Okay. If you need a copy constructor in your program but have not defined it yourself, the C++ compiler will create a default copy constructor. This default copy constructor copies values of all data members of subject object to the corresponding members of the receiver object or the calling object. So this is like the same as usual assignments. In many cases, the default copy constructor that the compiler generates for us is not good enough. Okay, so we're gonna see like some instances where the copy constructor that the compiler excuse me, generates for us is not enough in later examples, right? But in this case, when we don't have any dynamic member variables, when we don't have any pointers, like it's very simple static variables, this is optional. Like even the default the compiler generated default copy constructor would do exactly the same thing. So here you see an example here. So we have a class of myString, right? So like here everything is defined as public. This is like usually not ideal. We want to have our member variables as private and member functions as public. But let's just look at the example. So here this is, if you look at it, we have a function with the same name as our class. So this is definitely a constructor. What does it take? It takes an array of characters, right? It takes an array of characters. So this is a non-default constructor. It's a parameterized constructor. This one is a destructor, and this one, right? Look at it. We have a function that doesn't have any return type, has the same name as our class. It takes one parameter, which is an object of the same type as our class. It's a constant parameter. and it's passed by reference. So this is a copy constructor. Okay, this is a copy constructor, and we are initializing our C array and length here. So you'll see like how this is done here in this example. Another example that we see here, we have another class time, which has 3 private member variables, year, month, day. We have a default constructor and we have a copy constructor. Okay, so we have a default constructor, we have a copy constructor. So here, look at it. At this point, right, when instantiating T1, the constructor is called. Here, we are declaring T2, and at the same time, we are initializing it. So this is gonna call the copy constructor. Okay. In the next line, we have a dummy function that we are just passing an object to this function by value. We are passing by value. So when you pass an object to a function by value, it's going to call the copy constructor. So here you see that this object T, it's instantiating using the copy constructor by copying the values of T2 into T. Okay, so the year, month, day of T, it's going to be the same as those of T2. Okay, now what is the third copy constructor that you see here? Like, what is the third one? So if you remember, I mentioned that the copy constructor is going to be called in 3 different cases. This one is like dependent on your compiler, but here in this compiler it's called. So you see that here, this dummy function that we have, it returns an object. It returns an object by value. Whenever you return an object by value, so here we are returning T by value, right? But this T is a local object, right? So it's going to be destructed once we get out of it. So in order to return it to main, in order to return it back to the calling function, the compiler instantiates a copy of T in the background. We don't see that, right? We don't see that object. We don't see it like here. Like there's no name for it, right? So that copy object, that copy of T that is created in the background, it's going to be instantiating by calling the copy constructor. So here you see the 3 instances of copy constructor calling. When you are declaring and initializing at the same time, when you are passing an object to a function by value, and when your function returns an object by value. Okay, again, like you remember that like we can also return by reference, right? So like this case, when the copy constructor is called, is only the copy constructor is only called when you're returning an object by value, the same way that it's done here. We don't see any ampersand here, and we don't see any ampersand here. So like it's calling by value, it's returning by value as well. Another example you see here, so here we have a destructor, right? So we have destructor, and in this case, like I wanted you to try to see like what's gonna be printed when you are what's gonna be displayed on the screen when you run this program, right? So depending on your compiler, you might want to press F5 or Control F5 to see exactly what happens, right? So I wanted you to see that like any object that is instantiated, so here T1, T2, and T, any object that gets instantiated, right, eventually has to be destructed, right? So whenever it gets out of the scope, it needs to be destructed. So you see that T1, T2, and T, all of them are gonna call the destructor. So you should see the destructor comments on the screen. This is another example. We see like a default constructor, we see a non-default constructor, we see a copy constructor, and this is the assignment operator. Assignment operator. So what is an assignment operator? So here we are basically overloading a function. What function? So this operator, any operator can be treated as, can be thought of as a function. So like this is the function that we are overloading. So so here let's say like we have some objects t1, test1, test2, test3. So look at this one. Look at this one. Like here, when we say test3 is equal to test2, right? So this operator is usually defined for primitive data type, for integer, double, character, right? But what does it mean like when we say like an object of class test is equal to an object of class test, right? So in this case, like we have redefined or overloaded the assignment operator. Okay, so in this case, test3 is the calling object who calls this assignment operator. It takes one parameter which is of the same kind as, of the same type as our class. Right here, because we don't want to change test2, we define it as constant. And here, like you see that we passed it by reference. Here we also see that we are returning it by reference. We're going to see more about assignment operator later, but like I just wanted you to see what an assignment operator is. So we can overload different operators that we have. We can overload plus, minus, multiplication, division, like any operator that we have, except two operators. One of them is dot operator, the other one I can't exactly remember which one was the case, but most operators can be overloaded. So this is assignment operator. Again, this is a function that if we don't define, the compiler will generate that for us. And in the case of this class where we don't have any pointers and dynamic variables, the compiler generated assignment operator would be sufficient for us, would be enough for us. So it would do exactly what this one is doing. Okay, so the compiler would generate the default constructor, copy constructor, assignment operator, and destructor if we don't define them ourselves. In some cases, the destructor, the assignment operator, or the copy constructor that the compiler generates for us is not sufficient, right? So we have to define it ourselves. One other thing that I should mention and I should remind you is that I mentioned that the compiler generates a default constructor for you, like for your class if you don't define it. However, if you already define a non-default constructor explicitly, if in your class definition you define a non-default or parameterized constructor, okay, then the compiler would not generate the default one for you anymore. Right, because it said like, oh, you remember to do like a non-default one, right? So like there's no need for me to create a default one for you, right? So in that case, if you have a non-default constructor and you don't have the default one, if you try to instantiate an object that needs to call the default constructor, you're going to get an error because the compiler is not going to generate one for you anymore. So it's always a good idea to if you have like it's mandatory that if you have non-default, like I shouldn't say mandatory, it's a very good idea that when we have a non-default constructor, we write a default one as well, even if we don't use it. Okay, so here you see that this one, test1, is instantiated by calling the non-default constructor. test2 as well, it's gonna call the non-default constructor, right? This one, which function is called here? The assignment operator. The assignment operator is called here. Why is this not calling the copy constructor? Because copy constructor is called only when we are instantiating an object. Here, test2 has already been built, right? Each object needs to call just one constructor one time, right? It's like a building, right? You only build it once, right? Then you have the building done, right? So like you're not going to build it again on top of it, right? So this is calling the assignment operator. This one is calling the default constructor. This one is calling the assignment operator. And how about this one, test4? Which function is called? Which constructor is called to create test4, to instantiate test4? The copy constructor. So the copy constructor is called to instantiate test4, because here we are declaring test4 at the same time we are initializing it. Okay. One other example here, this is like a class of complex numbers. You see a default constructor, you see a non-default constructor, you see a copy constructor, assignment operator, and what else? That's it. Also like wanted to like remind you that like we also like can overload the insertion operator. So like here, this is done to basically be able to do like this line, C out, C2 and C3, right? If we didn't have this function, this line would give us an error, right? But because this is not defined for the compiler, like what do you mean? Like I want to create, I want to print an object, I want to see out an object. Which part of it do you want to display? Okay, so we have overloaded this operator as well, right? So this is also assignment, this is also operator overloading, right? So this is operator overloading. Okay. Again, for this class, the default constructor that the compiler generates for us would do exactly like not exactly the same, but like here just like we just like basically create an object. The copy constructor that the compiler generates for us, it would do exactly what we have here. It would just like copy member variables of this parameter, which is called other or right hand side, back to the member variables of the calling object. So in this case, here the copy constructor is called. The real and imaginary part of C1 are copied correspondingly to, respectively to, real and imaginary member variables of C2. Okay. Again, you see another example here from the same class. Again, we have all these operators. We also, okay, I wanted to also show you this part. So you see that we can also overload the plus operator. We can overload the plus operator. So here, using these three functions that we have here, all these operations that we have would have meaning. If we didn't have these three operator overloading, function overloadings, these lines that we are doing some arithmetic operation with objects of class complex would give us an error. So this is another instance of operator overloading. In this case, we are overloading the plus operator, and we can overload it multiple times. One of the cases is when your operator takes two objects, right? of class, right? So like one of them is going to be left hand side, one of them is going to be right hand side. This is I don't want to overwhelm you, but like this is a non-member function. We define this like outside the class. If we wanted to define this inside the class, that was possible. In that case, we only needed to have one parameter because we would have one calling object. I don't want to overwhelm you, so like don't worry about it. But like here, you see that in this case, right, we have a different set of parameter. We have a different parameter list. We only have one complex object, an object of class complex, and the second operator excuse me, the second parameter is a double variable, and here we have a double variable and a complex object. So here the orders are important. This one is on the left hand side, this is on the right hand side. The same thing here, left hand side, right hand side, left hand side, right hand side. So for this one, for example, C4 plus 7, right, this one is going to be called, this function is going to be called. Okay, but for example, for this one, 3.2 plus C6, it's going to call this one because 3.2 is on the left and the object is on the right side of the operator. Another example with the same class. Okay, so again, like you can run this and see like what happens here. So this is like what I mentioned here. You can define the this operator overloading function inside the class as well. If your class doesn't have an assignment operator as a member, the compiler generates one by default, just like it generates a copy constructor and a destructor and default constructor if you don't have one. Therefore, it will be angry if you try to define a non-member assignment operator later. Okay, so like here, like we defined a non-member plus operator. Like we don't do that for assignment operator. Assignment operator, it's going to be a member function. We don't want to have like two assignment operator, one member function, one non-member function. Well, this one depends on the compiler. Okay, so but it's not a good habit to have both of them. Another example, again using the same class, here you see that we have other operator overloading functions, so we can overload the Boolean operators as well, right? So here the equal operator and the not equal operator, we can also like overload them. So and then we can just like see like if two objects are equal. And what do we mean by equal? It's going to be defined in the class definition. Okay. Destructor is a function, is a member function that is should say member function that's automatically called once the object gets out of its scope. Okay, has the same name as our class, and just like before the name, like we have a tilde, it doesn't take any parameters, right? And we can only have one destructor for each class, right? For constructors, we can have multiple constructors, like one default constructor, let's say multiple non-default constructor, a copy constructor, but destructor, we only have one of them, right? And it's going to be called automatically when the object goes out of scope. This part is very important, automatically. Okay. So here again, I provided two examples here that are very similar, but like I wanted you to first like figure it out, like guess what the output is going to be. So here you can see that we have an object called Bob. It's of class cat, right? So when is this object going to call the destructor? It's going to call the destructor when it gets out of a scope. What is the scope of this object? Is within these curly brackets, these braces, right? So at this point, when we get out of this bracket, out of this block, right? So then the destructor for Bob is going to be called here. But however, for this example, which is very similar to this one, it just doesn't have those curly brackets. The destructor for Bob, it's going to be called when we get out of the main function, because the scope of Bob is the main function. Okay. So as a review, the Destructor is a member function, doesn't have any return type. Its name is tilde followed by name of class, doesn't take any input parameters, mostly used for bookkeeping and cleaning up before the allocation of objects. Okay, so again, if we don't have one, the compiler would generate for us. So for example, for this case where we don't have any dynamic variables, the one that the compiler generates for us is good enough. It just like destroys the object, right? But if we have dynamic memory, right? If we have dynamic memory, then we need to write our own destructor to avoid memory leak. Constructors are invoked or called automatically when an object of the class is instantiated or allocated. Object is allocated first, then constructor is invoked on object. It's a convenient way to initialize data members. So like you can initialize member variables of an object in the constructor. Destructor is invoked automatically or called automatically when an object of the class is deallocated. Structor is invoked on object first and the object is deallocated. Convenient way to do bookkeeping or cleaning up before deallocating objects. One other thing that it's a review for you is that like we mentioned that constructor are invoked automatically. In many cases we can explicitly call the constructor. So member functions of a class can be usually invoked explicitly on a receiver object of the same class. So for example, here you see that I have this expression here, this term here. What does this mean? Like this is the name of my class. It has 3 parameters here, right? What is this? This is basically the programmer calling the non-default constructor explicitly. Okay, so it's calling the non-default constructor explicitly. Whenever you do that, an anonymous object would be instantiated. So like here, we would have an anonymous object. Anonymous means no name, right? Like you see that the object that got instantiated here doesn't have any name, right? It gets instantiated, its member variables are initialized, right? And then we use the sum function to just like basically find the value of the right hand side and then we assign it to the left hand side. So this is called explicitly calling a constructor, right? So whenever this happens, an anonymous object is created. Usually it's an error to call a destructor explicitly. Okay, so we do it for constructor, but we don't do it for destructor. Why is it? And like usually an error, like in many compilers, an error to call a destructor because the destructor is invoked automatically. So if you also call it yourself, the compiler is going to call it automatically. So the destructor is going to be called twice on the same object. Right, it's like trying to demolish a building twice, right? So like once you demolish it once, there's nothing left, right? So like once the compiler wants to destruct it, there's nothing left. So like the compiler might give you an error. Destructor is opposite of constructor. It's a member function automatically called when object is out of a scope. Perform delete cleanup duties. default version only removes ordinary variables. Like ordinary here means non-dynamic or static variables. A class has only one destructor with no parameters. The name of this structure is distinguished from the default constructor by the tilde symbol. Right, so here you see that. For copy constructor, used for making a copy an object, is a constructor with one parameter of the same type as class. The parameter has to be passed by reference, and the parameter is usually a constant parameter. The constructor should create a complete independent copy of its argument. This one is very important, and we're going to see what this means, right? So like here, the copy constructor should create an independent copy of its argument. Okay. I mentioned about the three cases where the copy constructor is called when like you are class object declared and initialized at the same time, when argument of class type is plugged in as the actual argument to call by value parameter, when function returns class type is an object and you're returning by value. The default copy constructor here means like the one that compiler generates for us, performs only member-wise copy. We call this shallow copy, and we'll see like what that means. So the one that compiler generates for us, it would only do a shallow copy. For classes that have pointer type member variables, we need to write our own copy constructor because we need a deep copy instead of a shallow copy. The same thing for assignment operator. So if we don't write our own assignment operator overloading function, the compiler would create a default one for us. This one also does shallow copy. It does member-wise copy. Member variables of the given object are going to be transferred or going to be copied to the corresponding member variables of the calling object. This default version is okay for simple classes, but for classes having pointer type member variables, we need to again write our own assignment operator. Okay. Recall that dynamic variables are stored in part of the memory called heap. Don't get confused with the heap that you saw in the data structure lectures, right? So like they have the same name, but they have different meanings. These dynamic variables are not going to go away automatically. The compiler is not going to destroy them automatically. We need to delete them. We need to deallocate them. Otherwise, we would have something called memory leakage. So even if a local pointer variable goes away at the end of a function, the dynamic object it points to, it remains on heap unless delete is performed. A user of the certain kind class could not know that a dynamic array is a member of the class, so could not be expected to call delete when finished with a string type object. So that's why, right? So if we have dynamic variables, we need to like define our own destructor so that it takes care of these dynamic variables. Would deallocate them, would get rid of them. Okay, so the destructor in a certain class, like in this case, and this is an example, a string type class that has dynamic variables, has a pointer to dynamic variables, must call the delete to return the memory of the dynamic array. So like, or deallocate it to the heap, like make it available for the heap again. Okay, so here like this class basically had a pointer that points to an array, a dynamic array, right? So whenever an object of this class goes out of a scope, the destructor is called. If we don't write our own Destructor, it's basically like the default destructor that the compiler generates for us would not deallocate the dynamic memories, right? So like that's why like we need to have our own destructor. We need to define it ourselves. So let's look at what look more closely to the copy constructor. So again, imagine that this class, StringType class, right? It has a private member variable, which is a pointer, and it's gonna point to an array of characters, which is a dynamic variable, dynamic array. Okay. So here, this function, okay, so it has this is the scope resolution, this is the name of the class, a scope resolution operator. This is a constructor, don't have any return type. It takes only one parameter, it's constant, it's of the same kind as our class or data type, it's passed by parameter. This is a copy constructor. This is a copy constructor. Okay, so here, like if we write our own copy constructor, right? So like what we need to do, we just need to allocate a new array for the object that's getting created and then copy the array of the parameter, the array that the pointer of this parameter is pointing to copy that array into the array of the calling object. So you have to remember, when we design the copy constructor, we have to make sure that the object that we are creating is going to be independent from the object that is passed to the copy constructor. We don't want them to share anything, right? We want them to look alike, but they should be independent. Okay, so here, by like allocating a separate dynamic memory for this object that's getting instantiated, and then copying the array of the parameter into the array of the calling object, this is done. Okay, so this is done here. So if we don't write this copy constructor, the compiler is going to create one for us, right? So let's assume that we forgot to write our own copy constructor, and we're just going to rely on the copy constructor that the compiler generates for us. If that happens, right, so like if that happens, let's look at this one. So here we have an object called greeting, right? This object, let's say it has a pointer called value, right, that points to an array, a dynamic array. This part is done in a non-default constructor that we don't see, right? It has a pointer that points to this array. So here, this is like we have one object, and then at this point, we are calling a dummy function here, right? So like here, we are passing this object to this function by value. So you remember, when we pass an object to a function by value, the copy constructor is going to be called. For which object? For on which object? For this object, right? Because this is the same as saying that this string type object str is equal to greeting. So we are declaring it and initializing it at the same time. Okay, now once we do that, right, and we didn't write our own copy constructor, so the only thing that the default copy constructor that the compiler generates for us does, it's copying the value of member variables of greeting into the member variable of str. The only member variable that greeting has is a pointer. Okay, so it basically copies the content of the pointer, the value pointer of this object into the value pointer of this object. So what we end up with, it's this one, right? We have two objects. This is like one object called, sorry, this is the original object greeting, which had a value pointer that points to a dynamic array, dynamic character array. Okay, and then once the copy constructor was called, the copy constructor did only a shallow copy, right? It didn't create a, a version of this array for the str object. It only copied what the content of this pointer was into this pointer. So now what we end up with is that we have two pointers pointing to the same array. So now think about it. Are these two objects independent? No, they're not independent. They all like sharing the same array. Okay, now this is going to cause a problem here. Why? Because look at this one. So at this point, right, when we get out of this function, str is going to call the destructor. Now if we have a destructor that deallocates the dynamic array, right, so if we have a destructor like this one, right, so what's gonna happen? The destructor, it's gonna remove or deallocate this dynamic array, right? But this dynamic array is now shared for two objects, right? We wanted to only deallocate it for str, but because it's shared, then this one wouldn't have any dynamic array anymore, right? So that's the problem with not defining a copy constructor when you have pointers and dynamic memory in your class, right? So like in that case, the shallow copy is not good enough. Just copying this pointer into this pointer is not good enough. We need to define our own copy constructor. Okay, so what we want to have, it's something like this, right? We want these two objects to look alike, but they have to be independent. So how do we do this? Like this is called deep copy. We want to have deep copy. Like we don't just like want to copy the content of this pointer into this pointer. We want to go one layer deeper, right? And we have like we want to allocate a dynamic array for this pointer and then copy this array into this array. So this one is called deep copy, right? So like for copy constructor, when we want to define it, like when we have dynamic memory, we have to make sure that we do deep copy. Okay, so when a class definition involves pointers and dynamically allocated memory using new include a copy constructor. Make sure that you define your own copy constructor. Classes that do not involve pointers and dynamically allocated memory do not need copy constructor. The one that compiler generates for us is enough. Okay. Now there is a rule of thumb in computer programming. We call it rule of three or the big three. It's basically summarized here, right? You can read the whole definition here, but it's summarized here. The big three include the copy constructor, the assignment operator, and the destructor. Okay. If in one problem, for one class, you realize that you need to define your own copy constructor, then it means that you have to define, you need to define your own assignment operator and destructor as well. if you realize that you need to define your destructor, it means that you need to define your copy constructor and assignment operator as well, right? So if you need to define one of them, you need to define all of them. It doesn't mean that if you don't define all of them, you're gonna get an error, but it means that like if you need the destructor, it means that the copy constructor and assignment operator that the compiler generate for you are not gonna do good enough job for you, right? So here you saw that, for example, here in this example, we knew that because we have dynamic memory, we need to define our own destructor, right? We realized that we need to define our own destructor, otherwise we would have memory leak. As soon as you come to this realization, you should also know that, okay, I need to define my copy constructor and assignment operator as well, because the ones that the compiler generate for me is not good enough, right? So like here you see why this is the case, okay? And it works the other way around as well. Like if you realize that you need to have a copy constructor, it means that like you need to define assignment operator and destructor. So this is called the rule of three, or the big three, okay, which are these three member functions. I talked about shallow and deep copy. Shallow copy, it's basically copies only member variable contents over, right? So like here, like if you have a pointer, only copies the content of that pointer into the pointer of the calling object. So the assignment operator and the copy constructor that the compiler generates for us, like we call them default assignment operator and copy constructor, they do shallow copy. They do shallow copy. Now, if we don't have any pointers and dynamic variables, it doesn't matter because we only have one layer, right? So like there's no shallow and deep, there's only one level, right? But if we have pointers and dynamic memory, then we want to have deep copy. So in this case, we need to dereference the pointer variable to get to the data and then copy the data. What do we mean here? Like here, like it means that like if we have this one, we need to dereference this pointer so that we get to this memory, and then copy this array into the array that belongs to this object, right? So this is what this line means. Like in this case, like we know, in order to do deep copy, we need to write our own assignment operator and copy constructor. So the default C++ copy constructor and assignment operator does shallow copy. So it's like in the cases that we have pointers and dynamic memory, it's dangerous to use just basically skip defining copy constructor. So we have to define it ourselves, right? Because let's say like if two objects share the same array, right? They have pointers that point to the same array. Then if one of them decides to deallocate that array or change that array, it's gonna be changed for the other one as well. Okay, so like I always like use this example. Let's assume that there are two students, like you and your friend, right? And there is a computer glitch, and both of you in the system end up like with the same transcript, right? Now, if you're very hardworking and your friend is like not as hardworking as you, right? He's basically gonna mess up your transcript because there's a computer glitch that you share your same transcript. So this is the case here, right? So this is the case here. Like if we don't do deep copy, that this is the same as like two people sharing the same transcript, right? This is not what we want, right? We want to have two independent objects right? So we want this object to be initialized as a copy of this one, but later on we can change this one or we can change this one, and these two should be independent of each other. Changing this one should not change this one, changing this one should not change this one. Okay, so that's what this one means. The same thing, the same concept applies for assignment operator. Okay, like if we don't define our assignment operator ourselves, the compiler would generate for us, right? But this one also does shallow copy, so would have the same problem that we had here. Okay, so the same problem here. So in this case, we would have a shallow copy. We end up like with like two objects having pointers pointing to the same array. So the solution, right? The solution is, of course, to write our own copy constructor and write our own assignment operator. So like here, like we have to overload the assignment operator. So let's say how we can overload it. So here, like in writing this assignment operator overloading function, we're going to do some try and error. So we're going to go through some buggy implementations, and we try to modify it step by step. So here you see that so if we want to overload the assignment operator, just gonna have the name of the function, it's gonna be operator equal. It's gonna take one object which is gonna have the same type as our class. It's not gonna change, so we can define it as constant, and we can pass it by reference to avoid like having extra memory used. Okay, so this is, let's say like this is what we have, right? So like now if we define it like this, if we define it like this, okay, so here we're doing like here, like we say like integer new length is equal to length of this one, so we find the length of the right hand side, okay, and then we're just like basically what we are doing, just like copying copying the array of the right hand side into the array for the calling object. So this is like not what we wanted to do, because like you see here we didn't do any allocation, right? You have to remember that we have to allocate a new array for the object, right? So we have to allocate a new array for this object. So here we assume that like here like we already have an array, right? So like that's why like we got this size of this one and change the size of the array, but like we can't just like change the size of a dynamic array like this. Okay, so this is definitely faulty, right? This is definitely faulty. Like we can't do like this. So here like the version that we saw compares the length of the two string type objects, uses only as many characters as fits in the left hand side object, right? So here let's say that like if this like let's say like we say string 1 is equal to string 2, right? And both of these, they have pointers that points to an array. Now let's say that this array is smaller than this one, right? So in this version it just basically uses only as many characters as fit in the left hand side object and copies everything from that array into this one. So it does deep copy, right? This part is deep copy, but it doesn't copy the whole array. Let's say like if I go back here, like if here like let's say like here this one was a smaller array, right, or like bigger array than this one, it doesn't copy the whole thing here, right? It doesn't copy the whole thing here. Like if this one was a smaller, it only copies, let's say, few of the characters. right? Or if this was bigger, if it copies this one, the rest of it, it's going to be garbage value. So this implementation has some errors. So it makes an independent copy of the right hand object because it does deep copy, but it's not good enough. It has a problem. Usually we want the copy of the right hand argument regardless of its size. So it shouldn't matter like if the size matches or not, right? It shouldn't matter if the original left hand side object had an array smaller than the right hand side object or had an array bigger than the right hand side object. When you want to assign, like let's say S1 equal to S2, we want S1 and S2 have the same like array, right? Like their array should have the same value, not sharing the same array, but the array should have the same value, the same size. Okay, so to fix this problem, we're going to go through another implementation. So what we do here, in order to fix that problem, so like here, if you say S1 is equal to S2, right, the first thing that we do here, we say that, okay, so S1 has a pointer that points to dynamic array. Let's deallocate that dynamic array first. Let's deallocate that dynamic array first. Okay, then allocate, let's say this part, allocate a new dynamic array for the left hand side object with the same size as the array for the right hand side object. So like we're doing, like we deleted the original array and then deallocated, allocated new array with the appropriate size, and then we copied, this part is deep copy, we copied the content of the array of the right hand side into the array of left hand side. If you look at it, like the pointers, the value of the left hand side object and the right hand side object would have different values, right? Because they point to different objects. So we didn't just copy the value of the pointer from one to another one, right? We went one layer deeper, and this part is doing the deep copy. Okay, so this is slightly better than what we had before. Okay, now there are still like couple or like maybe 3 small problems here. Okay, so first of all, in many compilers you have to be careful when you use delete, right? So when you want to deallocate what a pointer is pointing to, you have to make sure that this is actually pointing to something, right? There's no guarantee that this pointer is already pointing to a dynamic memory. So this is something that we have to be careful. You should be very careful when using the delete function. Make sure that there is already a dynamic memory allocated. Make sure that this pointer is already pointing to dynamic memory. If your pointer does not point to any dynamic memory, or if you already deallocated the memory, once you try to deallocate your program crashes, right? This is compiler dependent, but like in many compiler, when you try to deallocate something that has been deallocated before or doesn't exist, like your program crash, right? So it crashes. So you have to be careful about that. Okay, so that's one problem. So like we have to check if this is already pointing to something. The other problem is that like we say that this implementation doesn't support self-assignment. Self-assignment is like if for some reason like somebody wants to do a statement like this: my string is equal to my string, a equal to a, s1 equal to s1. If you try to do that, right, the left hand side and right hand side is equal. So in this implementation, the first thing you do, you delete the array. You delete the array of the left hand side. But now our right hand side has the same, right, because they're the same object, right? They're the same object, right? This is self-assignment. So you delete this, right? And then you try to copy the array of the dynamic array of the right side into the dynamic array of left side, but you deleted it first, right? So like this one, this implementation doesn't support self-assignment. So one way to solve this is basically making sure that the left hand side and the right hand side are different, or basically the calling object is not the same as our parameter. Okay, um, and we can also like make some more modification here. So like you see, like this is like a little bit better than what we had before. So we are doing the deallocation, right? And then we do deep copy later. We copy the contents of the array of the right hand side into the array of the left hand side. There are other versions of implementing this. This is just one version. It's not perfect. You can make it better, but I just wanted to show you that how to debug your code. Like you do it step by step. Like don't try to solve all the problems at the same time. Try to just do it step by step. Okay. Another um, problem that this implementation has is when we have something called chain operation, right? Chain operation, when we say like A equal to B equal to C, right? The compilers should support chain operation, right? But this assignment operator that we defined doesn't support chain operation, because here we want to say, okay, B is equal to C, right? So like this is gonna call the assignment operator that we have, right? But so right here, actually this one works. Like this one, like here, like this one, doesn't give us any. Oh, actually it doesn't work, right? Sorry, this one doesn't work because we are returning void. We're returning void. So here, here, the first operation is going to be B equal to C, right? So like this one is going to copy all the variables of C into B. It's going to be done, but the return type is void. So the second operation is basically A equal to nothing, right? So then we're going to get an error here. We're going to get an error. So the solution for this, in order to have chain operation done, actually I don't have it, right? Sorry. In order to have fix this chain operation, maybe you can think about it yourself, but I can tell you what the solution would be, right? Instead of having void, right, you want to return, like in this case, after you assign C to B, you want to return B, right? So that the next operation would be A equal B, right? So you want to return the calling object. What is the type of the calling object is the same as our class type. So instead of void, we would have a string type. And then, so because our function is not void anymore, we have to return. What do we have to return? We have to return the calling object. But do I have access to the calling object? Yes, I do. If you remember, we have a pointer called this, right? The pointer this points to the calling object. So to fix that problem, right, we need to change the return type to string type in this case, it's going to be the name of our class, right? And then we'd just do return star this. Okay. I'm gonna leave it to this for the assignment operator, but in order to have perfect or like a better assignment operator implementation, you don't want to have your return type returned by value, right? So like you want to return it by reference. You want to return your calling object by reference. So like a better implementation would be string type ampersand, and then you would just like return star this at the end. So this would be how you define an assignment operator that would do deep copy. Okay, so this would be the same steps that we have to do an assignment operator that would do deep copy. What do we have to do for the copy constructor, right? Like, because like we said that like, okay, if we need to define our own assignment operator, we definitely need to define our own copy constructor as well. So now if this was a copy constructor, okay, we wouldn't have any return type. The name of our function would be the same name as our class, right? And this part parameter list would be the same. Okay. The only difference here is that when you are calling a copy constructor, it means that like your object hasn't been instantiated yet. So it doesn't have anything. It doesn't have any dynamic array or dynamic memory assigned to it or allocated to it, right? So there is no need for deleting. If we are doing the copy constructor, we don't need to do deallocation, because like we are basically building the object, right, from scratch, right? So like we are building the object from scratch, so there's nothing, like there's nothing here, right? So the only thing we need to do, we need to figure out the size of this array, allocate using this pointer, allocate a new dynamic memory that this pointer is going to point to, and then copy this array into the other array. Okay, instead of copying this pointer into this pointer, we're going to go one layer deeper and we're going to do deep copy. We're going to copy this array into this array. Okay, so that's the difference between deep copy and shallow copy. Okay, sorry, I'm jumping like in many like over pages. So like I provided like some examples like on how to define destructor, copy constructor, and assignment operator for binary trees. For destructor, like I'm not gonna go over them. Like this is like only for your reference. So for destructor, you can define it non-recursively, right? So we can define it non-recursively either using stacks or queues. Like so here you see that this implementation uses it uses queues, right? So what we basically do, we traverse through the tree, okay, and the traversal like here is level order traversal, like so like it's like first like we go through the level 0 and then level 1, level 2, level 3, and so on, right? And then we are deallocating all the nodes of the tree one by one, like so like we just like basically get to the leaf, deallocate, we go back, and then or like so sorry, like we start from the root and like we go all the way to the leaves and we deallocate everything that needs to be deallocated, because all our nodes are dynamic, right? So like in a binary tree, like we have like if it's reference based, like if it's implemented like using linked representation, then like it's dynamic, so we need to deallocate them. So this shows the non-recursive version of it. The recursive version, it's just going to be simple. So like here, like you have a helper function, right? So like this Destructor, it's calling this helper function, which is gonna which it is a recursive function. So what it does, it basically it just makes sure that the pointer that we have is not null pointer. If it's not null, it's gonna call the same destroy function for the left subtree or for the left child, and then for the right child, and then it would delete the node itself, right? So basically it's like very similar to what we did for traversal. So like if you think about it, this is same as left right node traversal or post order traversal. So like this is basically what's happening here. Okay, in the new C++ compilers, this can be done also like using the delete keyword, right? So like here, like it just like makes life easier. I'm not sure if this works on every compiler, but so what you can do is just like basically delete the left child. So like it would try to delete the child. Like once it tries to delete child, like it would automatically implicitly and recursively go all the way to delete the whole tree. So like it would just like delete left and delete right, and then that's basically the whole, because like you're just like calling. So here, like you say, like when you say delete left, it means that you have a left child pointer, right? So like it means that you want to delete your left child, and this one, it means like you want to delete your right child. So when you try to delete your left child, this one, it's going to automatically call the destructor. So the left child is going to call the destructor, right? And so like this is going to recursively go back here and call the destructor. So basically the left child is going to call the destructor, and here the right child is going to call the destructor. So this keeps going on from the root to the leaves recursively. And so like here recursion is implicit here. So this is another version of writing destructor for binary tree. For copy constructor, so again, like here, like you can also, like here I'm using helper functions, like, but you can do it in the function as well. So like here you see that we have a copy constructor for binary tree. So this is the name, let's say like this is a BST, so this is the name of our class. Our constructor, a copy constructor, has the same name as our class, right? It doesn't have any return type. It takes one object of the same data type as our class, right? It's constant and it has to be passed by reference, right? So what we do here, right? We initialize the root. Like here, this is the initialization list of this constructor. I'm not sure if you've seen this in your previous courses, but this is like the same as saying root is equal to so like here root is equal to the copy tree holder rhs.root. So like we are calling this function, right? So like here it goes here, this is like the this is the helper function for this binary search tree copy constructor, right? So basically what we want to do, we want the root of this object that is instantiated here, this tree that we want to instantiate. We want like instantiated tree that is a copy of another tree, the RHS tree, right? So we want the root of this one to allocate, like to basically point to a new memory location, right? And we want to start building a tree similar to the tree that we had, right? So like this is how it is done, right? So we pass the root of the original tree to this function, right? Well, if it is null, then like we don't have to build anything, right? If it's not, right, you see that we allocate a new memory location. We don't just copy the rhs.root into this root, right? We don't do shallow copy. We do allocation, right? We copy the data part. And again, we do the same thing for the left child and right child recursively, right? So like here, like we built like a copy of the root node, right? So like we have at this point, we have a root node, right? That's very different from the original tree's root, right? But it has the same data. And then we're gonna try the left child and then right child. And this is gonna go all the way up to the point that you get to a null pointer. So this is gonna recursively copy construct the binary tree, okay? So pay attention here, because when you like write your copy constructor, like it means that like we don't have any object, we want to instantiate an object, we want to build an object from scratch. So there's no deleting here like what we had in the assignment operator. But if we do assignment operator, now this is gonna be very similar. Again, like I'm not gonna go over that because this is your assignment, so I'm not like it's your job to figure out like what needs to be done, but I explained like how the assignment operator works. So in this case, right, so like you have to do deep copy, right, you have to do deep copy, but before that you have to make sure to deallocate, your tree, your original tree, right? So you just like basically have to just read, this is like deallocating your uh, tree, right? So like again, like this is very similar to what we had for the destructor, left, right, then node, right? So like using the post traversal, post order traversal, we're doing the deallocation of the original tree, right? You can modify this, like you can make it better. Like this is not a perfect implementation, it's just like here to give you an idea how to do this, right? So like we are deallocating the original tree, and then after that we're just gonna do deep copy, and our deep copy, it's gonna be similar to what we did here, just like I'm like showing like a different implementation with different function names, but this is exactly what we did here. So we basically copying the data and then calling the same function for the left child and for the right child, okay? So this is a brief review of the concept of destructor, copy constructor, and assignment operator for those of you who didn't see this in your previous courses. I hope that was helpful. Thank you so much.